What do you know about angles? Well, hopefully you know that there are many different types of angles. An angle by definition is when you have um, two rays that share a common endpoint. So what I mean by that is this point B on number one is a common endpoint. This ray and this ray share that endpoint. Generally, when we measure angles, we look at the amount of space that is between the two rays. And the tool that we use to do that is called a protractor. Now, you guys may or may not have protractors at home, but I want to show you how you use a protractor. And it's, if you remember from fourth grade, I'm going to line up number 4. So where you see this kind of sun in the middle here, there is a perpendicular joining of two lines right there. Those two lines need to um, center up on the vertex of this ray, of this angle. So you can see that the vertex of the angle is at that intersection of those two perpendicular lines of the protractor. Then this side of the angle is against the 100 or the 0-degree line. In the 0-degree line, you can see that there are two scales. There's this interior scale that goes from 0 to 180 from in a counterclockwise direction. And then there's this exterior scale or the upper scale that goes from 0 to 180 in a clockwise direction. The scale that you use depends on which way the angle opens. This angle is opening up this direction to the right. And so because of that, we're using the lower scale. So if you know that a 90-degree angle is looks like this. You have perpendicular rays that form a square corner. That is a 90-degree angle, and we call that a right angle. That is a right angle. Anything less than that, we have, in this example, where do we have angles? Ooh, sorry about that. Where do we have angles that are less? I am just not getting that moved. There we go. Angles less than 90 degrees. Well, number 1 is less than 90 degrees. Number 2, because the space between the rays is less than this space here that you see on the right angle. Number 3 is less than 90 degrees, and number 4 is less than 90 degrees. So let's take a look at the ones below. Now, number 5 is greater than 90 degrees. Number 6 is also less. When you are less than 90 degrees, we call this an acute angle. And when it is greater than 90 degrees, we call it an obtuse angle. Now, there's a couple of other terms that you need to know, and you may or may not be familiar with them, but when we have an angle where you have a ray that goes in one direction and the opposite ray starts at the same point but goes in the opposite direction, this forms what is called a straight angle. And the measurement of a straight angle is 180 degrees. And if you think about it, if I added a ray here, this would give us two 90-degree angles, and 90 plus 90 is 180 degrees. Now, going back to obtuse, we said an obtuse angle was greater than 90 degrees, but it's also less than 180 degrees. And that is because anything from a right angle to a straight angle would be considered obtuse, but once it gets to 180, it becomes a straight angle. Now, can we have an angle greater than 180 degrees? Yeah, we can. So let's say this was your ray, and it looked like this. Now, this is an obtuse angle. But this part is going to be greater than 180 degrees. This is called a reflex angle. And reflex angles are greater than 180 degrees. Now, what do you think happens? Well, we'll come back to that. We'll come back to that. I don't want to get ahead of myself here. Okay, so what I need you to do right now is to draw two lines that intersect but are not perpendicular. Okay? Pretty simple. Hopefully you're using a ruler to do that. Two lines that intersect that are not perpendicular. This is their point of intersection. Okay. Now I want you just to note how many angles are formed. Well, we have angle 1, 2, 3, and 4. There are 4 angles, and we can call them angle 1, angle 2, angle 3, and angle 4. So what we're thinking about is the measurement of these angles. Now, if you have a protractor, you could measure them, but let's say we don't have a protractor. Let's just say what we know generally about these. Angle 1 appears to be less than a 90-degree angle, so it is an acute angle. Angle 2 appears to be greater than 90 degrees, so I would call that an obtuse angle. Bring this back down. Something just not working very well for me right now. Okay, let's do the same thing with angles 3 and 4. What do you think? Well, angle 3 looks like an acute angle, and angle 4 looks like another obtuse angle. Now, if you drew them differently and number them differently, you might find something else. But is there any other thing that could happen here other than having 2 acute angles and 2 obtuse angles? Well, if you drew them perpendicular, you were asked not to, but what if you did? Well, we know that this is a right angle. Then this would also be a right angle, as would this one and this one, angles 1, 2, 3, and 4. So the sum of all of those angles would be 90 plus 90 plus 90 plus 90 is 360 degrees. What do you think the sum of all the angles are on the original 2 lines that you drew that formed 4 angles? Well, it would also be 360 degrees. And that is because they form a full circle. They form a full circle, right? The center of the circle, if you draw it correctly, would be that point of intersection, and the distance around the outside would be 360 degrees. There's relationships that exist with angles, and that's really what we're going to be talking about. So draw 2 more intersecting lines that are not perpendicular, please. And again, you're going to have 2 acute angles and 2 obtuse angles. The 2 acute angles are related to one another. They are called vertical angles. And vertical angles are the ones that are formed sort of opposite of each other. But in this case, mine that I have indicated here are both acute angles. It happens to be that they are going to measure the same thing. And you can see that if you were to measure one of the acute angles, it would match the other acute angle. Now, what happens with my obtuse angles? Well, this is obtuse and this is obtuse. They are also considered vertical to each other. These 2 are vertical and these 2 are vertical. So the obtuse angles are vertical to one another and the acute angles are vertical to one another. And they have the same measurement. Angles that share a side are called vertical or adjacent angles. This is an example of an adjacent angle. And the way you could draw this is you could start with an angle, let's say here, and then you could draw a third ray that's still part of that same vertex, and it would form now how many angles? Well, this could be angle 1, this could be angle 2, and combined could be angle 3. Now, what do you think the sum of angles 1 and 2 would be? Well, it would be the measurement of angle 3. Adjacent angles. All right, let's draw a right angle and label it angle RTS. Now, yesterday we talked about the correct way to label things. And so when we have an angle, you have the angle symbol in front, and then RTS is an important order. So R is going to be on one of the rays. That middle letter, that middle point is always going to be the vertex. And then the third point would be the opposite side. So this is R, this is T, and this is S. Now the R and the S could be reversed, but the T must be at the vertex. Okay, now what if I asked you for the measure of angle RTS? I want you to notice this is a lowercase m. When you see a lowercase m, it means measure. It wants a measurement. So I'm going to assume there's a square corner here because it is a right angle. So the measure of this angle RTS would be 90 degrees, and you must include that unit of measure. All right, so now another term that you need to know is complementary angles. Now this is written in a way that sort of gives you a clue of what it means. Complementary. So if you notice, we have a right angle on the outside here. Oh my goodness, hold on. I lost my spot. Okay, so we have an angle here. Oh, I keep losing it. This ray and this ray form a right angle. And I can indicate that with the square corner. So together they form a right angle. We have, though, three angles here. We have the right angle, we have what I'm going to call as angle 1 and angle 2. So if you were to add angle 1 plus angle 2, you would get what? You would get 90 degrees because together they form a right angle. When angles add up to 90 degrees, they are called complementary angles. They complement one another. Complementary angles add up to 90 degrees. All right, now I'd like you to draw a straight angle and label it angle ABC. So this is the vertex. It must be the middle point of B, and then A and C go on each of the rays. Now, what I'd like to do is add another ray so if B is the vertex, you have to draw it from point B, no matter what it is, okay? So now, the measure of angle ABC, if it's a straight angle, is 180 degrees, correct? Now, how many angles do you see now? Well, we had the original straight angle, but now we also have this angle, which I'll call angle 1, and we have this angle, which I'll call angle 2. If you add angle 1 plus angle 2, in this case, you would get 180 degrees. No matter what angle 1 and 2 measure, their sum has to be 180 degrees because we started with a straight angle. These are called supplementary angles. So complementary angles, their sum was 90 degrees. On supplementary angles, the measurement is going to be 180 degrees. The sum of any angles, when you put them together, if it equals 180 degrees, they are called supplementary angles.